Yep. Here they come, one after another, streaming in. As you come into the room, make sure your microphone is on mute. This is going to be a really intense session in terms of the Zoom traffic. You'll notice that as you come in, I do not have my video camera on. I have no expectation that you have your video camera on either. As we go through stuff, I'm going to have a minimum of video content from in terms of humans running around working. I will have tons of video content coming here shortly, and I'll go ahead and share the first piece of video content now. Of course, you're not interested in my password bank, you're interested in the syllabus. I'll go ahead and give this a little bit smaller of a size. Okay. We'll start 1 or 2 minutes late because I want to give chance for everybody to come into the room. And I also want to make sure that I have taken the best attendance that I can among the people who are in the room right now. I have a word session, and so I have one person in the room. And then when I look into the Zoom, show me participants. There we go. Thank y'all for your patience as we get this fired up. Okay. I have attendance taken. I have the syllabus in front of us. We're pretty much ready to go. I have company in the room. However, it's very limited company in the room. Most of y'all did follow the instructions I put in the email and turned up to class by Zoom. Thank you very much for doing that. I really do appreciate that a ton. Those of y'all who have lab this afternoon, let me go ahead and issue this reminder right now that we are not Zooming in for lab. I am going to run the lab in person, and that will be happening at 12:30 this afternoon in mean 312. Most of y'all have lab on Thursday afternoon, but there are a couple of y'all who crossed over into the Tuesday afternoon session. You'll find there will be a little bit more space, elbow room to maneuver around. We're right up against our COVID limit in the lab on Thursday afternoons. We're going to run the labs every week this term. There's not going to be any week off for the online lab and week on for the in-person lab. We're going to run lab every week. And this week's session in lab is just going to be a everybody get to know everybody else session. I'm going to have you in groups this week in lab. You're going to get to know group mates, and you're going to do a little bit of a fun lab safety exercise that practices your observational skill with your group mates. Let's put it that way. So be ready for that. It will. I've had somebody ask me coming out of class earlier this morning, how long did they? I think the lab was going to run today. The lab should run no more than an hour and a half, and maybe even a little bit less than that. Okay. Now, for those of you who haven't dealt with me at any point before, I am Pearson. You see on the syllabus in front of you, there's an email address for those of you who communicate with faculty members conventionally. There is a cell phone. It is my personal cell phone. Please feel free to use that cell phone number at any point in time. But when you give me text messages after 8:30, 9 o'clock in the evening or so, I'm very prone to sleep through them. You're not bothering me if you text me that late. You just have to be prepared to get the return message back from me at 5 o'clock in the morning when I get woken up and get going. Yes, that is my Twitter and Instagram handle. Please follow me on Twitter and Instagram. Yes, follow at Shorter Pearson on Twitter and Instagram. The Zoom link that is on the syllabus is for the personal meeting room. I'm going to have that Zoom link live Monday afternoons this term, Monday afternoons between 2:30 and 4:30 p.m. I'm going to have wide availability on Monday and Friday. When we actually get you into Mean 114, you'll see that I have computers set up in Mean 114. The tables are pretty broad in Mean 114. There's plenty of room on Monday and Fridays for you to come into Mean 114 and actually do some work on your own and get some face time with the professor. We're going to have definitely the Zoom hours available. And if you need to catch me by Zoom another time, we can make those times available by appointment as well. We do have the COVID-19 statement. It is still valid. We are still in the midst of a pandemic, and this is still pandemic semester. Please, please, please keep your masks on, do your social distancing. If you, for any reason, feel like you don't need to be in the room for one reason or another, that's why you've got my cell phone number. Please don't hesitate to text me and let me know. And I'll reiterate that as we go through this syllabus talk. Okay. Now, course meeting, because of the size of this section, we can't have you in this meeting all at once. That's why you're jumped into the meeting on Zoom right now. I will designate a certain day of the week, Tuesday or Thursday, for one group of y'all in the room. And if I designate that day for you, you should only turn up in the classroom on that day, and you should Zoom in the other day. You always have the right to Zoom in both days. Your attendance in the classroom is welcomed and convenient, but it is absolutely optional. This session will always be running on Zoom. This session will always be recorded on Zoom. And when we get done with this session, I will very deliberately save this to Studio and Canvas and make sure it's uploaded into the Canvas course when the Canvas course turns on, which the Canvas course is not turned on yet, and I will save you my follies with sapling learning, but my follies with sapling learning have been substantial. So be aware that the lectures will always be recorded. If there's any reason for you to duck out of a day entirely, we'll have the lectures available to you to view later on. Okay? I'll go through the course description later. I'll talk about the math prerequisites a bit later. The course prerequisite is Chem 101 with a grade of C- or higher. That's just Chem 101 is the prerequisite. The Chem 101 lab is officially not a prerequisite for the course. So if there's anything that went goofball with the lab in your fall term and you need to pick up the lab grade again, you're still quite welcome and quite allowed to be in Chem 101, Chem 102 now. It's the students who have a D in Chem 101 that I really am looking sideways at and saying, really, you should not be in Chem 102. And C's and C minuses are warning shots. They're signals that, yes, by all means be here, but recognize that you're going to have to pick up the work rate and you're going to pick up the things that you do to be successful. There are course learning outcomes that will be assessed with the ACS exam. I'll talk about the ACS exam in a little while. Yes, there is a lab report required in this course. We'll talk about that in the lab session later this afternoon. It will run towards the end of the course. Let me talk about the text. If you saw the syllabus talk in Chem 101, you heard me do a bit of talking about the text, but there are still plenty of good copies of the text in the bookstore. So I want to make something really clear about the text. Those of y'all on Zoom should be seeing the homepage of something called OpenStax. Y'all see that? I'm not hearing any complaints from the people on Zoom, so I'm presuming y'all are seeing the OpenStax page. OpenStax is the project that provides the textbooks that we use. Actually, it turns out both in chemistry and in physics. Note that I say it's the project, it's not the publisher. Okay, they certainly do publish textbooks, but when you buy an OpenStax textbook, you're not giving money to some fat cat Wall Street firm. And the cost of the textbook is substantially not down from what you would pay for some major publisher text. And it's going back to Rice University, that you see up here, so that they can continue to sustain this project and provide more textbooks for more people coming on down the line. Our textbook for this course is Chemistry 2nd edition, Atoms First. And when you go through the OpenStax website to access the textbook, you can view the textbook online. You can download an app for your phone that allows you to see the textbook. You can download a PDF of the textbook for your e-reader. And those resources are completely free of charge because the material in the textbook is completely free. Now, if the material in the textbook is completely free, why do I make such a big deal about it in the bookstore? Please buy it. Because I really do believe in this OpenStax project and I want to support the OpenStax project. And if you are a student of means, now if you don't have money to buy one more textbook, please don't buy one more textbook, okay? Don't go broke doing this. But if you are a student of means and you have the ability to do so, buying the textbook for this course supports this Rice University project to make more of these open textbooks freely available to those who really need to have textbooks freely available. We're still daydreaming about an OpenStax organic chemistry textbook. That's like one of our pipe dreams in this open education community. So any investment you can make, or if you don't want to buy a textbook, you don't need to have a hard copy running around. Yes, there is a Give Today link and you can actually just give money directly to the OpenStax project. I believe in this project. I have actually helped to edit one of the textbooks in this project, the physics textbook. It's a project that's worth supporting, okay? Now that's the main textbook and you'll always have links to the main textbook available through the Canvas course when the Canvas course comes online. The Canvas course is not online yet because I'm still going back and forth with Sapling, making sure you can have access to the homework through the Canvas course. The Canvas course will be online later this afternoon. One additional supplemental textbook I want to bring out is the textbook that is the study guide for the ACS examination in general chemistry. This is purchasable through the American Chemical Society Examinations Institute. You can find this through your standard Amazons and your other things. It's a supplement. It's not a required resource by any stretch of the imagination. However, it is a spectacular study guide for the final exam we will do in this course. And it gives you model types of questions that appear. It's also in reserve in the library. So you can access it in the library as well. Okay, calculators. How many of y'all have the big fat TI-84 graphing calculators that are running around that you had to buy for high school and or really? How many of y'all have learned how to use the big TI-84 calculators running around in there? Hey, I got somebody in the chat saying, yes, I do. Thank you for using the chat. Please feel free to use the chat as appropriate. Okay. I don't need you to have one of those TI-84 calculators running around. If you're in the classroom, I have an example of a TI-30 calculator in here that's much simpler and much more straightforward to use. I'm deeply fond of the Casio FX300 series. That many of those calculators you can find at Walmart for under 10 bucks. And they're really the extent of calculator you need for this thing, and they're give you the mathematical tools you need. I'm not going to take away your big fancy TI-84, but that's got a bit more power than you really need for what you need in this course. Okay? If I did nothing else right there, I provoked everybody in the Zoom session to use the chat. Feel free to use the chat and feel free to ask questions as appropriate as I go through the syllabus. And as I see them pop up in the chat, I'll make sure that they get answered. Okay? And yes, we'll talk about the lab safety equipment in the lab this afternoon. We'll have lab goggles available for you. I'd like for you to have a quad-ruled composition notebook for note-taking. It's not required, but it's really, really nice to have around for doing some of the work we're going to be doing in this semester in the lab. Okay? Course objectives key to textbook and calendar. I'm just going to focus on the topics in the list themselves. In the OpenStax Adams First textbook, the chapters that I'm going to focus on are chapters 8 through 17. 8 by way of review, and I'll say a few things in chapter 8 before we get done with this session this morning. 9 is the traditional point where Gen Chem 2 content begins. There will be topics that I consider overflow. Now, I'll cover overflow topics if we fly through the textbook chapters and get everything done in nice, neat form. However, I know the moment I hit thermochemistry, I say the word enthalpy, and enthalpy is frequently a new word to folk. And there we go, what in the world is enthalpy? And we spent a good bit of time talking about what enthalpy is, and we get bogged down immediately. My expectation is we're not going to wind up taking the time to do the overflow topics. My instinct that is going to be that we focus on chapters 8 through 17. And frankly, I deliberately have left chapter 11 out of this list because I think it's going to be topics that we're not going to have time to cover. And I'm prepared to cut chapter 16 out of this as well, because that will be a topic above and beyond what the core material that we really need to have in hand. It starts talking about energy. Gen Chem 2 largely is a course about energy and energy in the physical sciences. And then the physical sciences broadly, When we talk about gases up front, we're talking more physics than we're talking chemistry. We're not talking about any changes in the gas. We're talking about ways to characterize the gas. And this really fits neatly with who I am and what I do. You may not have picked up on this in the first course. I'll emphasize it now. My undergraduate training is not in chemistry. It is in physics. My graduate training is in a discipline called biological physics, where biology, chemistry, physics, and computer science all come together into one interface. And I use a lot of those tools to solve problems. So I have chemical background. I particularly have chemical background when it comes to biological systems, and acid-base behavior is huge there. There's a lot of stuff I cover in this course that comes back and haunts you when you get into biochemistry. So I make a big deal out of that. But a lot of what I talk about, especially early in the course, is about physical change and physical measurements surrounding physical change. Heat and work are key ideas in what I wind up talking about early in the course. So be prepared for this to feel a little bit physics-y, especially early in the course, before we get in the second half of the course to talking about chemical equilibria and talking about some really sophisticated chemistry ideas. Okay? Any questions about the schedule of topics arranged in the course? Okay? Evaluation methods. When we took the online course, those of you who were in the online course in the fall, we had these interactive readings that took the place of lectures. Well, you're going to have lectures in this course. You're going to be able to see me face to face and hear me run my mouth, or at the very least, hear me over this Zoom session running my mouth. Okay? So the interactive readings go away. We focus on sapling learning as our main means for assigning homework. You're going to be responsible for completing homework assignments through sapling learning. Okay? And I'm going to do my level best to make sure that the sapling learning assignments you have, you can do as many times as you need to get full credit without penalty to you. The dominant homework type that I assign on sapling learning has that no penalty for incorrect answers assigned to it. So you can try it as many times as you need to without getting penalty. You get credit for getting the thing right. You don't get credit for getting it right the first time or the second time or what have you. Okay? I am going to use Moodle every now and again, kind of like the way I use the chemistry server in the fall term. Those of you who are in the online course to deliver a lot of content, I'll use Moodle every now and again to give you practice in addition to what's available on Sapling. I didn't talk about this with the 8 a.m. folk. I need to remember with everybody on Thursday to talk about how I'm going to have y'all do review stuff from Gen Chem 1. So taking notes to myself now. So it's an 800-point course. Homework is 250 points towards your final grade. That's approaching 30% of your final grade comes from homework. Stay constant on homework. It's really going to help you get your grade right. Okay? Now, several of you may be familiar with another professor in this department and his policy that if you get maximum points on homework, he like bumps up your letter grade and stuff. I don't do that. I want to make sure the syllabus says I don't do that. But if you do complete all the homework and you have maximum points on homework, I do consider that when I set the final grades, and I make sure that I take the students who have demonstrated big work rate and I make their grade appropriate for the work rate they put in. I'm never going to promise, but as a general rule, if a student does maximum homework, that student should never be talking about the CD line in this course. Maybe that student's talking about the BC line. Okay? I hope as we're talking about the AB line. Now, there's one other online structure I want y'all to use. Okay? And I have made sure I've mentioned this in the email prior to this point as well. I want you to use a learning tool to build up your math skill. Those of y'all who had orientation in the fall should have done a math assessment of sorts to make sure you're appropriately placed in math courses going through. The tool you use to do that math assessment is called ALEKS. Okay? One of the grand theories behind using ALEKS in this course, in this math curriculum, is that ALEKS is always available to you, and you can use ALEKS to do practice on your math skill and build up your math skill. Now, there's no math prerequisite for Gen Chem 2. There used to be when we got into the point where the math curriculum got reformed and ALEKS came into the view, we dropped the math prerequisite to make sure everybody got the math background they needed in the course to move forward. And I'm going to teach this course as if there's no math prerequisite. However, I also want you to build your math skills so that you, when you do the reading in the course, you're not overwhelmed by the reading. And so 50 points of your final grade will be assigned for practice and improvement using the ALEKS mathematics learning system. And you either are a freshman and got access to that through your 2020 Orientation 105 section, and you did it for math placement, or you're a sophomore or junior and you need to have access to ALEKS given to you to get these points. I have access codes for those of you who are sophomores and juniors in this course. All you need to do to get your ALEKS access code is email me and ask for it. And I'll make sure you have instructions for enrolling in ALEKS as well. Okay. And there are two standards to get maximum points for the ALEKS grade: either investment of no less than 8 hours of mathematics practice over the course of the term, which sounds like a lot, but it's 8 hours over 14 weeks. So it should be able to space out pretty well. Or when you actually do an assessment on the tool for a score of 76 or higher. And 76 means you've passed all background understanding necessary to take calculus 1. Okay? Questions about the ALEKS thing? Again, I will have links available to you when we get Canvas turned on. Canvas will be turned on come heck or high water later this afternoon. I'm sorry about the delays getting Canvas online. We've had, I'm not going to go into the delays. It's been a comedy of errors. But we will have Canvas available to you later this afternoon. We're still using the assessment structure, even though we're meeting in person. We can't all be in the same room at the same time to take the traditional exam. And so just for everybody in the course, I'm going to give assessments in the exact same format I gave in Gen Chem 1 this past fall. For those of you who didn't take Gen Chem 1 this past fall, it comes in 2 parts. The first part is a 20-question, 30-minute quiz. And it's a 20-question, 30-minute quiz that I programmed very deliberately so that everybody in the room sees different questions and It's not just a matter of looking over somebody's shoulder to do the exact multiple choice and get the exact same answer. Hopefully, misconduct like that is punished by the assessment itself long before I catch it. Okay? When you take your 20-question, 30-minute quiz, if you spend any time looking at somebody else's 20-question, 30-minute quiz, you're going to see different questions. They'll be formatted in a way that's assessing the same material, but the questions will be shuffled around, and some questions will be deleted and other questions will be added to somebody else's attempt. And you're really going to have to be able to look closely to see what I've done. And if you look that closely on a 20-question, 30-minute quiz, you've hosed yourself because you've run out of time to do other things. So that's the practice that I really find it helpful for students at this stage, particularly those of you who have some type of board exam for medical school or dental school and the like in your future. Though that type of exam pressure really does help you prepare for such things. But I don't want to base the entire grade on that. So half the grade is based on that, and half the grade is based on a more relaxed 60-minute session where you're sitting down with some open-ended problem solving or conceptual questions that you can take a great deal more time and a more relaxed circumstance on. And my hope is you recognize that for one of those questions, it doesn't matter what you put as an answer, as long as it's a good faith effort, you're going to get maximum points on that question. And so, especially on that second half of the assessment grades, I like to rig the game in your favor. Okay. So that format of assessment is something to get used to. I will have exercise on Moodle, especially for those of you who didn't take the online Gen Chem 1, that will help you get used to it. We'll unleash that here in the next couple of weeks. And then there's the ACS final exam. It is nationally standardized. It covers material from both Gen Chem 1 and Gen Chem 2. I know what material on Gen Chem 2 we focused on. I can bias how I use the assessment towards that. But it's something I really want you to do your best on under all terms. Because it's a nationally normed exam, when you take this ACS assessment, you're competing against students not just at Tusculum and not just at institutions like Tusculum. You're competing against people at places like Tennessee Tech at UT, big state schools that use these exams. And you're competing against the elite boys at Harvard and Yale and such as that. So when you actually take this exam that's written for that type of audience, and if you put yourself in a position where you can score 90% plus on that exam, that's not just top 10% at Tusculum. That's top 5% in the country. Okay? A score of 50%, 35 out of 70 questions, is a fairly strong score on this exam. Okay? You get into the 40s, you've done really well. You get into the 50s, hello. Okay? So, and I use this to support your grade. Again, it's a thing where I try to take a lot of the stakes off and I scale. And those of you who have been through my Gen Chem 1 already know I take these exams very frequently and upfront say, these exams cannot hurt your grade, they can only help it. I don't quite say that in Gen Chem 2. Please don't Christmas tree the exam. I can tell when you've just randomly guessed on everything and your grade tends to reflect that, and that might hurt you. But if you make a good faith effort on the ACS final exam, you'll find that that grade only helps you. And that will be a thing I emphasize more as we go through the course later Grading scale for the course, I prefer absolute grading. Oh, come back here. There we go. I prefer absolute grading scales for my courses. I want everybody in the course to be able to get A's. I don't believe that only 5% of the people in the course should get A's, and then 15% should get B's, and 50% should get C's and crap like that. Okay? So I give an exact scale. I say all these add up to points. If you get 744 of those points in the course, that is an A. And that gets the A done and dusted and over with. Okay? I might bump that scale down, but I'll never bump it up. I'll never take 745 points and say that's an A minus. Sorry about it. I may take 741 points and say, oh, that's an A2. Okay. So I want you to work towards your best performance at all times. But if the course comes back and behaves really, really rough, if we get through those first couple of assessments and the average grade on those first couple of assessments are coming in the 50s or 60s, I will be aware of that and I will make adjustments about how I'm grading those assessments accordingly and what letter grade we assign to them. Okay. Anybody got questions on how we grade? Very, very good. Okay. Attendance policies. If this is the only thing you read, I'm fine with it. If you feel sick, don't show up in the room. Period. The end. Over. If you're really feeling the effects of a bug, don't feel like you even have to jump into Zoom. We're recording these lectures for a reason. You can pick up on what you need to be doing after the fact. It'll benefit you to be live. It'll benefit you to be able to give me feedback and ask questions. But if you feel sick, then dadgummit, be sick and don't feel like you got to apologize to anybody for it. Is that clear to everybody? Hearing no complaint. When you need to be out of the room, I have a very simple excused absence policy. It is this: if I know about it ahead of time, it's excused. Now, if you say, Pearson, I'm not going to be in class for the next week or so because I'm going to the beach, number one, I'm going to say it's a daggum pandemic. What are you thinking? And number two, I'm going to say that's an excused absence. Okay? I reserve the right to judge if you're out of the room for dumb reasons. I know athletics is a thing right now. It's going to be more of a thing as we get into the semester. When athletics is a thing for you, just let me know ahead of time. Absolutely, you should try to get in on the Zoom whenever you can. But again, we're recording for a reason. Okay? But do let me know ahead of time when you're not going to be around. I don't like to be surprised. And I get annoyed when I'm surprised. I'll deal with it. We're in a pandemic. I've got to deal with it somehow. But please make sure that I'm aware. Okay? Academic misconduct. I've got links to the Tusculum University catalog on academic misconduct here. Okay? I'm going to be really, really selfish here. I chair the committee that's responsible for reviewing stage 3 cases of academic misconduct and assessing the penalties. That process sucks. It's wretched. I hate it. Okay? Don't cheat so I'm not miserable. This is me being selfish. Obviously, don't cheat because it diminishes your own understanding and diminishes your own appreciation. Obviously, like I said before, I rig the assessments online so that the reward for any attempt to cheat is no reward at all. It's frankly punishment just by the nature of the assessment itself before I make any discovery. Even on the homeworks, make every effort to do your own work and do the work on your own terms. Frequently on the homework, if you get an answer for somebody else on a question, you try to enter it into Sapling, you're going to find that that answer worked for them, but it don't work for you. And it may not be entirely obvious from looking at the question why that answer don't work for you. You need to understand what's being asked in the question deeply in order to understand what you need to do to solve problems that are assigned specifically to you. Okay? So my hope is when I set up the course, I've got enough tricks up my sleeve that any attempt that you might make to cheat is going to cause you more problem than it's going to cause you benefit before I'm even aware that you're making the attempt to cheat. Okay? But be aware of the policies. Be aware of if I discover academic misconduct, there are specific things I'm required to do in the event of an infraction that I don't get a choice in the matter of. Okay? Be aware of that and conduct yourself accordingly. That's pretty much the syllabus talk as it stands. The last sections, no, there's one other thing I need to say in the syllabus. And I had a lot more people in the room where I ran the 8 o'clock hour. So I made my introduction for the policy on electronics in the classroom by talking about the student I had in an astronomy class one time. Remember, I come through physics. The student actually was tapping on their phone back when tapping on the phone in the classroom was first starting to become a thing. I feel like I'm going to be high and mighty. I'm going to call this person out and say, yeah, Barbara, what are you doing on your phone in the middle of class? She just showed me her phone and said, you got the density of Mars wrong. And she was right. I had the density of Mars wrong on the board, and I had to erase it and fix it because she looked up the data that I had botched coming from a different source. So electronics in the classroom are powerful. It allows you to look stuff up and actually be more educated on what I'm talking about in the classroom if your head is on and you're aware of what I'm talking about in the classroom at a given time. So you should use electronics in the classroom, but you should be critical about it. And you should be aware that there are times when I have to say, you can't use the electronics in the classroom here. If you're taking an exam, happens only one time in the term, conventionally. It happens at the very end of the term with the exam of the American Chemical Society. This is the last sentence in this paragraph. It says, be aware we may use assessments over the course of the term that are standardized and that are subject to external requirements that by contract forbid the use of network devices. Specifically, when you take an American Chemical Society exam and you're taking the proper paper exam, there is a rule and there's a statement we sign off with the American Chemical Society. It says nobody may have a camera in the room where the exam's being taken. Hey, guess what has a camera that we all carry in our pockets all the blasted time? So you take one of those paper exams, I have to take your phone. Not because I don't trust you, because that's the rule provided by the exam providers. Okay? So again, misconduct here is very clear and very vivid, but it's enforced not merely by, oh, do not cheat, do not be a bad person. It's enforced by, well, the American Chemical Society says if you're going to take this test, there can't be a camera in your possession while you do it. Okay? That should go without reasoning. If you make any use of a phone, computer, or other electronic device with a camera or internet connection for any reason during the taking of an exam, that will be considered misconduct, the grounds for me to take your exam and give you a grade of 0 for that exam. We know that that's obvious. Okay? If you're not taking an exam, by all means have your phone. But keep yourself present in the room while you do. Okay? It is very permissible for you to take something I scribbled on the phone and Snapchat it to somebody else and say, what the crap is Pearson on about this? Okay? And you may find somebody else in the room understands a little bit better and can explain. Or you may find that nobody understands and somebody just needs to stop me and say, Pearson, you're on crack. What are you on about this? Okay? And I'll stop and I'll explain myself a little bit better. Okay? But use electronic devices critically when you do. Sometimes I'll ask you to use an electronic device like a cell phone or a computer to run some sort of simulator, like the simulators we used in the first course in the interactive readings. We'll see how this goes and we'll see what we actually have that we can take advantage of as we go forward in the course. I just ask that you trust me that I know what I'm doing. That I've been teaching this course and courses like it for over 2 decades of my life. And when I ask you to do something, I've got a pretty good reason to ask you to do it. But don't believe me blindly. By all means, test what I do. By all means, if I give you a tool that you can play around with one way, play around with it a different way and see how it works for you. Any good science stands up to any test you apply to it, and so you should look up explanations and solution methods and understand the science. I can fix my own syllabus on the fly. Understand the science rigorously on your own terms. I have no idea what channel was doing. Any questions about the syllabus? Any questions over administrative stuff at all? Okay, once again, note that I do not have my camera on. I don't see that anybody in here has their camera on. There is no expectation that you have your camera on because a lot of what I'm going to do in here is going to be on this little whiteboard program right here. Okay? And so what you will typically see in a classroom setting, regardless of whether you're in the classroom or whether you're on Zoom, is this little Microsoft whiteboard window where I can actually doodle and say, now I'm not going to ask you to take notes on hi, how are you? And I'm not going to write that chicken scratching. I'm just going to sketch a little balloon here. And we're going to take a good 20, 30 minutes here at the end of the class to do a little bit of a review and bring a few ideas back to our brain about gases and how gases behave. This is the part of the program where I'm in class mode, and if you are the type of person who likes to take your notes, this is the part of time where you should be taking notes. Okay? And if this is the type of time where you like to give your feedback, the chat is there for you to give feedback. I want you to think about and give me an answer to this question. There is a gas in this balloon. Okay? If I got the balloon blown up, there's some sort of air, some sort of gas inside this balloon. How do I measure what's going on inside that balloon? How do I measure the properties of what's inside that balloon? Give me a property of the gases inside that balloon. Somebody just think of something and toss it into the chat. What property dictates how the balloon behaves? There are any number of different answers you can give here. Okay, here we go. And we get three good answers coming right off the bat: density, pressure, and volume. Let me take these one at a time. Okay. First, density. What's the definition of density? The definition of density is mass per unit volume. It's going to be some way for me to characterize how packed together, how much mass there is for a given volume of the balloon. And so density has basic metric units associated with it. Say grams per liter. Okay? Mass per unit volume. Okay? Now, I think that takes into account somebody else's answer as well. Let me bring that chat right back, because I think I saw somebody say volume. Yes, indeed. And I'm going to use a different color for volume in my note taking here. Volume's just how big of a space in 3 dimensions the balloon takes up. Then I had somebody come back with pressure. What does pressure mean? You don't have to type this one into the chat. If you do, I'll see it, but think about it just for a minute. What does pressure actually represent? If something's under pressure, if a gas in a container like a balloon is under pressure, the gas in that balloon is pushing out on the walls of the balloon. It's exerting force on the walls of the balloon. And we define pressure specifically as that force pushing out on the walls of the balloon per unit area. And we'll talk about a precise definition for pressure when we get back together on Thursday. But for now, I'm just going to put pressure over here. I'm going to use red for it again. I'm going to give the units that we used in Gen Chem 1 to describe pressure, the units of atmospheres. Okay? Now, those are 3 different quantities we can come across that describe what's going on in a gas. Those are not the only quantities we can come up with. What are some other examples of quantities we can come up with that describe what goes on in a gas? Somebody else can come up with an idea in the chat. Mass is absolutely something we can talk about regarding behavior of the gas, and it fits very neatly alongside density, doesn't it? Okay, density is mass per unit volume. So we can talk about the mass of a gas in units of grams. Now, despite that, we don't tend to use that chemically as a way to describe the state of the gas. Mass Mass goes differently for a balloon that has helium inside of it than it goes for a balloon that has normal air inside of it. And it goes very differently than a balloon that has krypton, one of the noble gases inside of it. Krypton balloons tend to fall pretty fast. So the mass of the balloon doesn't tend to be how we characterize the amount of gas inside that balloon for our study chemically. We tend to use a different measure for how much gas is inside the balloon. Somebody take a wild guess about what that quantity is. When I did chemical calculations, what did I convert mass into? Person in the room saw me write moles on the board and groaned audibly. I know the feeling. I know the feeling well. Yep. 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 And I'm sure those of you who are behind the Zoom screen are groaning a little bit yourself as well. We use moles to characterize the amount of gas in a balloon for chemical purposes, because then it's no longer us comparing the mass of helium to the mass of krypton. It's us comparing the amount, the number of molecules or atoms of that particular gas in the balloon. Moles goes back to our Avogadro's number story, 6.022 times 10 to the 23rd power of something is a mole of something. We'll remind ourselves of that very quickly with the mole concept when we get into starting to do homework. Okay? So volume, pressure, and moles are three quantities that are known as quantities of state. Okay? They're quantities that allow us to characterize properties of a gas in a container. Volume, pressure, and moles give us a set of information that we can rely upon for knowing how the gas in a container behaves. There's one more quantity of state, one more property we can measure about this balloon in this container. And this property is really, really good to connect with the energy of the gas in the container. And Gatana puts into the chat immediately temperature. Absolutely. Temperature is our final quantity of state. And we're good metric students in here. We study temperature in the metric system just like we're supposed to. Hey, what units do we use to measure temperature in? This is a trap. Don't fall in the trap. If you're thinking Celsius, you're falling into the trap. What units do we? Yes, it's Kelvin. As soon as I said you're thinking Celsius, you're falling into the trap. Everybody is right there. It's important for us to measure temperature in Kelvin because we don't like negative numbers. We don't want to measure temperature in a way that gets us a negative number response. Excuse me. Because if we do, we're going to have relationships running around between volume and pressure and temperature that are directly proportional relationships. If we have a negative temperature, it means we have a negative volume or a negative pressure. And I don't know how we have a negative volume or negative pressure. That's really weird. Okay? So we prefer to have a scale for temperature where 0 is the lowest possible temperature and all of the temperatures are higher than 0. All the temperatures we can practically access are positive. And that makes our mathematics for these quantities of state work very, very well. So when you characterize a gas, mass is useful, density is useful, do not get me wrong. But the quantities of state are the most useful, and they're the quantities I want you aware of time and again. Volume, pressure, moles, and temperature. Okay? Now, if I'm going to be really complete, like I said, I need to make sure you're aware of getting back and forth between other units. We're going to talk about other units we can measure in these things when we get together on Thursday. But let me remind you of one other thing that we want to have in hand when we're talking through these quantities of state. It's a mathematical relation between these quantities of state that defines how a gas can behave. Many of you have dealt with this equation of state before as PV equals nRT. You recognize that? PV equals nRT is the statement we know as the ideal gas law. I actually prefer to write PV equals nRT a little bit differently than that, though. I prefer to write it this way. It's the same mathematics. If I just multiply both sides by n and t, I can get PV equals nRT back. But what this relationship says is, if a gas behaves ideally, if a gas behaves under a certain set of circumstances at low temperature, at high temperature, and room temperature is high temperature enough, and low pressure, and atmospheric pressure is low pressure, then pressure times volume divided by number of moles divided by temperature is a constant. And we call that constant R. And that constant has a characteristic value that doesn't change. Okay? Now, hidden in this relationship, PV over NT equals R. How many of y'all learned gas laws in high school? If you're familiar with the gas laws, the nature of the gas laws themselves are hidden behind this thing. You probably didn't learn immediately the ideal gas law. You probably learned first thing something called Boyle's law, or something that I call the pressure volume law. And the pressure volume law says that if you hold everything else constant and you increase the pressure on a gas, what happens to the volume? If you increase the pressure on a gas, does the volume go up or does the volume go down? It goes down. Pressure and volume are inversely proportional to one another. If you increase one, you decrease the other, and vice versa. That means the product of pressure and volume is constant. You may recognize this as P1V1 equals P2V2. You heard that before. Well, this rule has P times V in the numerator. P times V is a constant. Here's another. When you actually take a gas and increase the temperature of the gas, what happens to the volume of the gas? Does the volume of the gas go up or go down? If you increase the temperature of a gas, the volume of the gas, you increase the temperature of the gas, the volume of the gas goes up, the gas expands. Okay? And that means volume and temperature are directly proportional. That's written as volume divided by temperature is a constant. Well, here's volume divided by temperature here. And if you went really deep into studying these gas laws in high school, you might recognize pressure divided by temperature is a constant. P1 divided by T1 equals P2 over T2. Pressures divided by temperature in this relationship. You might recognize increase the number of moles of the gas, you increase the volume of the gas. V over N is a constant. Well, V is divided by N in this relationship. Okay? A lot of these really elementary gas laws come back to the way that the quantities are related to one another in this statement of the ideal gas law. Okay? Now, when you take a general chemistry textbook and open it up, and you study what's going on inside that general chemistry textbook, very frequently you come across mathematical statements like this. And you come across a value of this ideal gas constant, R. And I'm never going to ask you to memorize this ideal gas constant. It will always be provided to you when you need it. Now, many of you will wind up memorizing this ideal gas constant, and the only reason you'll memorize it is because you wind up using it so much. Okay? When you're practicing solving problems, oh, it's 0.082058 again. I'll use that number again. I'll use that number again. And when you've used that number enough times, you wind up memorizing it. Okay? But in many textbooks, you also see a different number. And the different number you see is this. Now that capital J in the numerator stands for joules. Who knows what you measure with joules? Drop into the chat if you got it. This capital J, this measure of joules. Who knows what you measure with joules? It's actually a pretty important thing to know. This, got somebody in the chat recognizing that you measure energy in joules. That is correct. Okay. The joule is a unit of energy. And this ideal gas constant has information about energy wrapped up in it. It actually turns out that when we study gases and when we study the behavior of gases, these stories give us a great wealth of information about energy of the individual molecules and the way that energy can be transformed from one state to another, and that can be expressed in the behavior of the gases. And it turns out that the product of volume and pressure of the gas has information about energy embedded in it. Our task is just to figure out how we're going to fish that out. And so we're going to start working on fishing that out when we get back together on Thursday. And the way we're going to fish that out is we're going to figure out a few additional things about these units of pressure and volume and different ways to express pressure and volume and how to get pressure and volume into these different units that make this 8.314 number more useful than the 0.082058 number. And we'll do a little bit of problem solving to make sure we understand how to best example how we're going to use these things. Okay? Don't go anywhere yet. I'm going to stop the record of the session here. I'm going to stop the sharing here. But what